Hi guys, let's see today's question. So today's question I have picked up from the topic of integration. Let's understand the question first. So they are asking us to find the value of alpha such that the expression is given to us that says 4 times alpha, integral goes from -1 to 2 and the function is an exponential function e raised to minus alpha mod of x dx equals to 5. They are asking us to find the value of this alpha. For this expression that should be satisfied. So let's find out the answer for this. Before beginning with the solution, let's first understand the concept of modulus of x. So modulus of x or absolute value of x, you know that mod of anything will always turn out a positive value because mod is nothing but the distance on the number line, right? So if x is greater than 0 means if there is a positive value within the mod, we write it as it becomes x. But if there is a negative value inside the mod, what we do is, for example, if I have, let's say, I have mod of -4. What do we do here is we remove this negative sign and write it as it is. Or in other case, I can also justify this as whenever there is a negative value numeric entry present inside the mod, we multiply this by -1 to get a positive value for that answer, right? So same thing, if x is negative, what we do is this x which is present inside the mod is a negative, and since we need a positive answer for the mod, we multiply this by -1. So basically it becomes minus x, right? So minus x which is already negative is getting multiplied with minus and becomes a positive value, and hence we get mod positive. So this is the concept which we'll be using here in the question. So if you see this expression 4 alpha x, the limits goes from -1 to 2. So I'll separate that first because we have -1 to 0 as the values of x, for which mod of x will become different, because if x becomes less than 0, mod of x becomes minus x, right? So I'll separate that. E raised to minus alpha mod x dx plus the remaining limits, I'll write it in a different integral, 0 to 2 e raised to minus alpha mod x dx. That's equal to 5, correct? So 4 alpha. Now, when the limits go from -1 to 0, it is e raised to minus alpha x. So -1 to 0, e raised to minus alpha. Now mod of x when x is less than 0, we already know it as minus x. So if I replace this mod of x, I can write it as minus x dx 0 to 2 e raised to minus alpha. Now here if you see the limits of x are greater than 0, so mod of x is a positive value x. So I'll write it as it is x dx equals to 5. Further, for alpha, the limits are from -1 to 0. It is now minus alpha into minus x, which is alpha into x dx plus 0 to 2, the limits, and it is e raised to minus alpha x dx equals to 5. Now let's solve these integrals. We already know e raised to ax. So the integral of an exponential function is always the same exponential function. So e raised to ax. Now we have to divide it by the coefficient of x. So it becomes e raised to ax by a, right? So same thing if I do in this, the expression now turns 4 alpha, the limits, first expression integral of e raised to alpha x, that is e raised to alpha x upon alpha, limits go from -1 to 0 plus the next bracket, if I solve it, it becomes e raised to minus alpha x. So e raised to minus alpha x upon minus alpha. Limits go from 0, and that expression turns out. Now 4 alpha, I can see I can take out alpha common from both of this. So I'll take that common, 1 by alpha is common. If I apply the limits now, it becomes e raised to alpha into 0, which is 0, minus e raised to minus alpha plus I have taken alpha common from both of these terms, but minus sign remains, so minus 1 is left in the denominator. And here also, if I take this limits, it becomes e raised to minus 2 alpha and minus e raised to 0. That's equal to 5. Alpha cancels, 4 is left. E raised to 0 gives me 1 minus. This becomes e raised to minus alpha plus e raised to minus 2 alpha minus 1. The whole is divided by minus 1. So now if I apply this idea, it becomes 4, 1 minus e raised to minus alpha. Now if I multiply this minus sign with this positive sign, it becomes minus. So minus of the whole bracket equals to 5. So if I solve this further, it becomes 4, 1 minus e raised to minus alpha minus 2 e raised to minus e raised to minus 2 alpha. So we do not have a 2 here. I'll erase that. And plus 1. That's equal to 5. If I solve it further, it becomes 4. So if I multiply everyone by 4, 4 minus e raised to minus alpha minus 4 e raised to minus 2 alpha plus 4 equals to 5. So here what I get is, if I take everyone on the right hand side, I have 4 e raised to minus 2 alpha becoming positive plus 4 e raised to minus alpha also becoming positive, and 5 plus 4 if it goes here becomes minus 4. So 5 minus 4, 1, and plus 4 again if it goes here becomes minus 4. So 1 minus 4, that is minus 3. So I get minus 3 equals to 0. So I get this equation with me. Now let's solve this further. I have 4 e raised to minus 2 alpha plus 4 e raised to minus alpha minus 3 equals to 0. So I have this equation with me now. Here, if I keep e raised to minus alpha as, let's say, any other variable, let's say x. So the equation now becomes 4x square plus 4x minus 3 equals to 0. So quadratic equation, if I solve this, it becomes 4x square plus 6x minus 2x minus 3 equals to 0. So 2x common, 2x plus 3 minus 1, 2x plus 3 equals to 0. So x I get here as half and minus 3 by 2. So I get two values of x. If I resubstitute x, because I do not need x, I need alpha, I can resubstitute as e raised to minus alpha is 1 upon 2 or minus 3 upon 2. So e raised to alpha, if I see, it becomes the reciprocal of this. So 2 and minus 2 by 3. Now, as we know that the exponential function is always positive irrespective of the variable, right? So e raised to alpha can be 2, but it cannot be minus 3, right? So this becomes an inconsistent solution. We cannot go ahead with this. So the only solution I'm left with is 2. So e raised to alpha becomes 2. If I take log on both sides, it becomes log alpha, the log of e raised to alpha. So it becomes log of e raised to alpha, and this becomes log. So alpha log e equals to log 2. Now since the base here is e for both of them, log e to the base e is 1. So alpha becomes log 2 to the base e. And this is the value of alpha which we get. If you see the option which matches in that question, that is A. So the correct answer for this question is A. I hope you have understood this, how to apply the concepts of absolute values as well as the integration. I'll meet you again tomorrow with the next question. Till then, you can like, share, and subscribe if you are finding this helpful. Thank you.